So we're going to do recording of extra sums in differentiation, where the first sum that I'm going to try is if y is equal to root of 4 plus root of 4 plus root of 4 plus x square. This is the question. So when such a question comes, I'll square both sides. Y square is equal to 4 plus root of 4 plus root of 4 plus x square. Now I'll take this 4 to the other side. Y square minus 4 is equal to root of 4 plus root of 4 plus x square. Now again I'll square both sides. This y square minus 4d whole square is 4 plus root of 4 plus x square. Now I'll take this 4 to the other side. And I can also expand this, which is y to the power 4 minus 8y square plus 16 minus 4 is equal to root of 4 plus x square. You agree with me? So it's y to the power 4 minus 8y square plus 12 is equal to root of 4 plus x square. I won't do squaring both sides anymore because I know differentiation of root x is 1 by 2 root x. So I'll keep it like this. Now I can start differentiating this. It's 4y cube into dy by dx. I'm not going to write it. I'll write it later. 8 2 is 16y into dy by dx. Plus differentiation of this is anyway 0. So I can write it into dy by dx in total is equal to root x differentiation is 1 by 2 into root of 4 plus x square. And you have to differentiate, it will become 2x. 2 and 2 gets cancelled. So therefore dy by dx is x by root of 4 plus x square into 4y cube plus minus 16y or something like this will be. What is y? Y is a question, is this question, and I don't like to substitute that y here because it becomes chaotic if I do that. Just leave it like this. This is my answer. Are you clear? This is the first sum where you understand that when it's the square root, you tend to square both sides and take it to the left hand side until there's only one root on the right side. Are you clear? So can I go to next sum? The second sum, the extra sum that I'm going to do is if root of 1 minus x to the power 6 plus root of 1 minus y to the power 6 itself is a cube into x cube minus y cube. Prove that dy by dx is x square by y square into root of 1 minus y to the power 6 by 1 minus x to the power 6. Do that. In the hint, I'll tell you what is the hint here. Can you see there's an x cube here and there's x to the power 6 here. There's a y cube here and there's y to the power 6. So I can write this as x cube the whole square so that there's a symmetry on both sides. Correct? So I'll write this as root of 1 minus x cube the whole square plus root of 1 minus y cube the whole square is equal to a cube into x cube minus y cube. I am going to introduce you to a method called substitution where I can substitute x cube as sin c. So 1 minus sin square c will be cos square c and root of cos square c will be cos c. Similarly y cube, I can substitute it as sin d. What is x cube is sin c. Therefore c is sin inverse of x cube. And y cube is sin d. Therefore d is sin inverse of y cube. Taking it to the other side. Are you clear? Now we are going to substitute this here. Be root of 1 minus sin square c, which will be cos square c, which will become cos c because root and square get cancelled. So this will become cos c and this will become cos d is equal to a cube into, what will this become? Sin c minus sin d. Cos c plus cos d. What is the formula for cos c plus cos d? 2 cos c plus d by 2 cos c minus d by 2 is equal to a cube into sin c minus sin d is 2 cos c minus c plus d by 2 sin c minus d by 2. Last year's formula. Where 2 and 2 gets cancelled. Cos c plus d by 2 gets cancelled. You can bring this down and write it as cot c minus d by 2 is equal to a cube. Take the cot to the other side. C minus d by 2 is equal to cot inverse of a cube. Take the 2 also to the other side. So can you see right side is fully constant? C minus d is some constant. What is c from this? What is c? C is x cube. C is sin inverse of x cube. And d is sin inverse of y cube. So sin inverse of x cube minus sine inverse of y cube is equal to k. I haven't even differentiated. I've just solved it. I've solved the question. Now only I have to differentiate. And you should know differentiation of sine inverse of x is 1 by root of 1 minus x. Specially put together. Upper x cube will be x cube the whole square, and chain rule is 3x square. Okay. So let's differentiate this. So let's differentiate sine inverse of x cube, which is 1 by root of 1 minus x to the power 6 into 3x to the power 2 minus 1 by root of 1 minus y to the power 6 into 3y square into dy by dx is equal to 0. That's what we'll forget. And so this is equal to this, no? So you can cancel this and equate these two, and 3 and 3 get cancelled. So x square by root of 1 minus x to the power 6 is equal to y square by root of 1 minus y to the power 6 into dy by dx. This can be taken to this side. This can be taken to this side, and thus you get your dy by dx, which is your... Auntie, suppose I forgot that I have to do substitution method. Supposing in the exam I forgot about substitution and I do it straight. Root of 1 minus x to the power 6 plus root of 1 minus y to the power 6 is a cube into x cube minus y cube. You forgot. This itself is capital X. 1 by 2 into root of 1 minus x to the power 6 into minus 6 into x to the power 5. Chain rule. Plus 1 by 2 into root of 1 minus y to the power 6 into minus 6 into y to the power 5 is equal to a cube into 3x square minus 3y square into dy by dx. In you have to have a dy by dx and consolidating. Isn't the answer looking ugly? But you will still get the answer. But I prefer substitution method for this. What gives me an idea of doing substitution is x cube becomes x to the power 6 and a y cube becomes y to the power 6. So I can write it as 1 minus x cube the whole square plus root of 1 minus y cube the whole square, and sin c and a sin d. We'll make it cos c and a cos d here, and right side la sin c minus sin d. I can straight away use the formulas and then solving becomes very, very easy. Can I go to next question? The third question, if y is equal to sin x the whole to the power, sin x the whole to the power, should I make it more thicker for you to see? Thirumurugan, make it thicker. Sin x the whole to the power, sin x the whole to the power, sin x the whole to the power, sin x assume till to the power infinity. That use to the power infinity. Very good. Do you know from here to this is infinity is y now? From here to here is also y. So imagine my height. I am taller till the sky. Little bit cut my neck na. Will it reduce my infinity height? I'll still be little less than infinity, which is still infinity only, no? Correct? Just taking a sign from here doesn't make it any less. So you can write this as y. Question. So y is equal to sin x the whole to the power y. And a variable to the power variable means you have to apply log on both sides. So log y is equal to log of sin x the whole to the power y. Konde can come to the Monday. So log y is equal to y log sin x. You're going to differentiate this. You do it as u and v. Log y is 1 by y into dy by dx. Is write it as it is. Second one, differentiate 1 by sin x into cos x. Sin x differentiation cos x, chain rule, plus log sin x into y differentiation itself is dy by dx. Consolidate dy by dx. So it's dy by dx into 1 by y minus log sin x. Taking it to the other side, correct? Is equal to y cot x, because it's cos x by sin x is cot x. Therefore dy by dx is y cot x by 1 by y minus log sin x. So when you take LCM, dy by dx will be y cot x by 1 minus y log sin x, and the y goes up and will become y square. Correct? The y in the denominator LCM. Like this you will get different answers, and that's the proof. They are asking you to prove that this is the answer, and we have proved it. Okay, what was it? It's sin x the whole to the power, sin x the whole to the power, sin x to the power infinity. So one of the sin x, you take it off and write it as sin to the power y. Y is equal to sin to the power y. Applying log on both sides. differentiating it as u and v, consolidating dy by dx, you get the answer. Are you clear? Clear? Can I go to next question? So next question is the fourth question of the day. Y is equal to root of sin x plus root of sin x plus root of sin x plus dot dot dot, it goes up to infinity. You know, you can leave 1 and write this as y. So therefore y is equal to root of sin x plus y, squaring both sides. Y square is equal to sin x plus y. Differentiate this. 2y into dy by dx. Sin x differentiation is cos x. Y differentiation is dy by dx. So consolidate this. Dy by dx therefore is 2y minus 1 is equal to cos x. Therefore dy by dx is equal to cos x by 2y minus 1. What is y? You can't substitute from the question because it's very complicated. Y itself goes up to infinity. Just leave it like that. This is my proof. Are you clear? Clear with this question? So can I go to next? Next question is the fifth sum for today. If y into root of 1 minus x square plus x into root of 1 minus y square is equal to 1. Prove that dy by dx is minus root of 1 minus y square by root of 1 minus x square. Something like this. So in this sum, I am thinking, can I do substitution? Because it's like sin a cos b minus cos a sin b pattern. Look at the pattern. 1 minus x square now it can be substituted as sin and cos. Because 1 minus sin square c will become cos square c and eventually it will become cos c. Correct? So, I can either do it normal method in this or I can do substitution. For me, substitution only will strike first. Y into root of 1 minus x square plus x into root of 1 minus y square is equal to 1 means 1 differentiation itself is 0. Right side. Here I am going to write y as cos sin a cos b. This I want it as sin, so x has to be written as cos a. Because only when I write x as cos a root of 1 minus cos square a will become sin square a, therefore it will become sin a and it will become sin a cos b. Otherwise it won't become sin a cos b. You understand? So y is cos b and x is cos a. So what is b? Is cos inverse of y, and what is a? Is cos inverse of x. Just leave it like that. Go to the question. Substitute this. This will be cos b sin a plus this will be sin a x cos a sin b, which is equal to 1, which is sin of a plus b is equal to 1. Take the sign to the other side. A plus b therefore is sin inverse of 1, and a sin inverse of 1 is pi by 2. Sin 90 is 1, so sin inverse of 1 will be 90. What does a stands for? A here is cos inverse of x. What is b? Cos inverse of y is equal to pi by 2. I haven't even differentiated. I have just substituted and solved it. Now I have to differentiate. A cos inverse of x is minus 1 by root of 1 minus x square. A cos inverse of y is minus 1 by root of 1 minus y square into dy by dx is equal to constant differentiation c. So minus 1 by root of 1 minus x square is 1 by root of 1 minus y square into dy by dx. Taking this to the other side, you got what is dy by dx, and this is the proof that they want you to find. The proof is minus of root of 1 minus y square by root of 1 minus x square. If I do it substitution method, it's very easy. But if I don't do substitution method also, I'll still get the answer. But for me, substitution method is easier. Don't you think so? Just become familiar with substitution method. So let's go to next question. The next question is the sixth question for the day, is differentiate cos inverse of 1 minus x square by 1 plus x square with respect to tan inverse of x. It's the world's most important question. It's not with respect to means you are writing your exam with respect to 100 marks, which is 100 marks with respect to is always in the denominator. So this has to be denominator and this has to be numerator. You have to differentiate. You differentiate and write the numerator's answer on the top. Differentiate and write the denominator's answer at the bottom. That's what it means. Now let's differentiate the numerator, which is cos inverse of 1 minus x square by 1 plus x square. Substitution. Because you know cos inverse of cos 2 theta and 1. So that cos and cos will get cancel. So how to make it cos 2 theta? By substituting x square, x as tan theta. 1 minus tan square theta by 1 plus tan square theta. Basic formula is cos 2 theta. Cos 2 theta in terms of tan is 1 minus tan square theta by 1 plus tan square theta. Sin 2 theta in terms of tan is 2 tan theta by 1 plus tan square theta. Tan 2 theta in terms of tan is 2 tan theta by 1 minus tan square theta. You know all that. So therefore I am going to use substitution, where I will substitute x square as x as tan theta. So it will become cos inverse of 1 minus tan square theta by 1 plus tan square theta, where theta here is tan inverse of x, which is cos inverse of cos 2 theta. The answer therefore is 2 theta, which is 2 into from here tan inverse of x. I have only solved the substitution. I still didn't differentiate. So I have to differentiate 2 tan inverse of x, which is 2 by 1 plus x square. This is the numerator differentiation of numerator. Let's do differentiation of the denominator. What was the denominator's question here? Is tan inverse of x, which is 1 by 1 plus x square. Just divide this, you get 2 as your answer. With respect to meaning is differentiate the numerator, write it on the top. Differentiate the denominator, write it at the bottom. That's what with respect to means. Are you clear? Clear? World's most important sum, again substitution. Most of the places I'm doing substitution. Do you realize that? Please become familiar with the substitution method. Okay, let's go to the next question. Next question is the 7th question of the day. If x to the power y is equal to e to the power x minus y, show that dy by dx is log x by log of ex the whole square. This is x to the power y is equal to, say, variable to the power variable. So I'll take it and apply log on both sides. Log of x to the power y, which is y log x, is log of e to the power x minus y, which is log x minus y log e. Log of e to the power x minus y, where the condyle comes from under x minus y log e. Are you clear? Put it within the bracket here. Now we have to differentiate this. When you differentiate this, this is u, this is v. And this is u, this is v. Correct? So y log x, in which y is u and log x is v, and x minus y into log e. Log e is just a constant. Log e to the base e is 1. What is log e? Log e is nothing but to the base e. So answer is 1, ignore. So now let's do it as u and v. முதல்ல இருக்கிறது அப்படியே ரெண்டாவதுக்கு டிஃபரன்ஷியேட் பண்ணா 1 by x plus log x into dy by dx is equal to x differentiate பண்ணா 1 minus y differentiate பண்ணா dy by dx. Consolidate dy by dx. It's log x plus 1 is equal to 1 minus y by x. So dy by dx therefore is இது LCM எடுத்தா x minus y by x into 1 plus log x. But look at this. They have asked for the question log ex. Do you know log? This can be written as log e. 1 is log e. X minus y by x into log e to the base e is 1 plus log x. So that this will become x minus y by x into log of ex. Because log a plus log b is log ab. Log of ex. But in the question it says log ex the whole square or something. How am I going to do that? Look at what I am going to do. You want x minus y. Just go back here and look at this. You can see what is x minus y. It is nothing but y log x. Can we substitute here y log x? Y log x by x into log of ex. But still I need what is y by x. Why? Because in the proof, to prove log x da irukku men. So you only need log x, you don't need the y. What is y by x? Okay, what you should do is you consolidate what is y from here and do y by x. What is this? Y log x is equal to x minus y. Y log x is equal to x minus y. Take the y to the other side. Y into log x plus 1 is equal to x. Y therefore is x by log x plus 1. 1 itself is log e. Therefore it's x by log xe. Correct? This is y. So bring the x also down. It's 1 by log x. y தான கிடைச்சது. Bring the x down. Y by x is nothing but 1 by log x. So log x by log ex the whole square. Hence proved. Very, very important. The book sums will not be like that. The both sums will be like this. Are you clear? Understood? I'm not doing one more code because it's recorded. You can play it and see. And you still have doubts, you can come back anytime and ask me. Only you don't have time. Otherwise, you can ask me anytime. Now there's no time for you. You all have exams. So next question is the 8th question of the day. If x is equal to a into cos theta plus theta sin theta. X is equal to a into cos theta plus theta sin theta. You'll do dx by d theta. Isn't it a book sum? A into cos theta differentiation is minus sin theta, and theta sin theta has to be differentiated as u and b. First term update, differentiation of sin theta is cos theta, plus second term update. So sin theta get cancelled. We just saw it, a theta cos theta. We just saw it, a book sum. Next term, it's been given y is equal to a into sin theta minus theta cos theta. Let's do dy by d theta, which is a into what is sin theta differentiation? What is sin theta differentiation? Cos theta minus this is u and b. But since this is a minus, you have to open a bracket. Cos theta into minus sin theta plus cos theta get cancelled. You have a theta sin theta, and a theta sin theta by an a theta cos theta is what is dy by dx. A theta get cancelled, thus you get tan theta to be your answer, correct? They'll ask you double differentiation. I told you, no, d square y by dx square will be secant square theta into d theta by dx, which is the reciprocal of dx by d theta, which is 1 by a theta, which is 1 by a theta cos theta, which is secant cube theta by a theta. That's all they're asking for, d square y by dx square. Are you clear? Can I go to next sum? Next sum again is only a book sum, but again double differentiation they are asking. I told you in every book sum will be converted into double differentiation sums. So the 9th question is if x is equal to a into theta minus sin theta and y is equal to a into 1 minus cos theta. Let's differentiate this. Dx by d theta is a into 1 minus cos theta, because theta differentiation is 1, and dy by d theta is a into 1 differentiation is 0, and a cos theta differentiation minus sin theta, ekune minus irukku, so plus sin theta. So this by this, second by first, a sin theta by a into 1 minus cos theta. I taught you this sum again. 1 minus cos theta is 2 sin square theta by 2. A sin theta in itself is 2 sin theta by 2 cos theta by 2. The 2 and 2 get cancelled, power and power get cancelled, it becomes cot theta by 2 will be my dy by dx. Supposing they ask you double differentiation, they are asking you here, cot theta is minus cosecant square theta by 2. Theta by 2 differentiation is into 1 by 2, so you can put it in the front, right? What will you forget? D theta by dx. What is d theta by dx? It's the reciprocal of dx by d theta. What is it? It is here, no? 1 by a into 1 minus cos theta. So it will be 1 by a into 1 minus cos theta. It's minus half cosecant square theta by 2. This itself is 1 by a is also there. 1 minus cos theta is 2 sin square theta by 2. Yeah, a 2 sin square theta by 2. 2 and 2 will make it 1 by 4a. This will become cosecant to the power 4 theta by 2. Where they are asking when at pi, means theta is pi. So 1 by 4a into cosecant to the power theta pi by 2. What is pi by 2? 90. What is cosecant 90? Sin 90 is 1. So cosecant 90 is also 1. So answer is 1 by 4a. How is it? Superb sum. So let's go to next.